though I was asked to take this title. So, but believe me, I'm still a scientist. I put a little bit science in this talk, but most of them is more strategic thinking rather than the science itself. But believe me, I'm still a scientist. So, why I use the word X diseases, plural form, instead of singular form, disease X? Because in my opinion, disease X more or less means we don't know what it is. This is why WHO named it as a disease X. So I cannot talk anything about what we don't know. I can only talk something that we know, or we do know, or we did know, or we have known. How can I know something we don't know? So this is why I changed the talk name as X diseases, and also more importantly, strategic thinking. So before talking something about disease X, let's think about diseases could mean at least 3 categories by definition of WHO's health. In 1948, when the WHO was established, they claimed health means a state of complete physical, mental, social well-being. So when we are talking about a disease, we talk so much about maybe physical health, not mental, even not social. Why we are getting here together? Why everybody is smiling here? Because you are healthy socially. So socially healthy is very, very important. Here we meet the friends, we are talking, and we smile at each other. We have a party, we drink some wines, for example, last night, or something like that. Socially well-being, social health is very, very important. This is why when we are talking about X pathogens, X diseases, you also need to think about social well-being. And mental, so also it's important. So physically, everybody knows. We are here, we don't have the wheelchair because we don't have the polio anymore. I do have this spot on my face because smallpox is not here. So this is physical, mental, and social well-being. So I don't want to touch more. I'll focus on more pathogens because of my my research field. But remember these 3 categories for healthy. Now, so for the WHO definition of disease X, unknown pathogens, we don't know what it is, but we can have a guess. Most likely what we would have. And also known pathogens, so this is WHO's definition. The time and the place of the outbreak and epidemic are unknown, but we have some rough idea what kind of pathogens we might encounter, we might have. To be honest, everybody knows, though we have a COVID-19 and SARS-CoV-2, but all the professionals, we know if we have a pandemic, it could be either flu or corona. It's already known. From that sense, it's a known pathogen this time. It's not unknown. So, disease X in 2018 by WHO, they defined some of the list. Crimean Congo, Ebola, Lassa fever, MERS, and SARS. We heard, United 2018, they named SARS as well. Nipah, Hanipah, there's a lymphocyte city here, the discovery of these diseases there. Rift Valley, Zika, and blah, blah. In 2024, last year, they relisted their R&D blueprint in the WHO. They put these priority pathogens. And look at this. All the viral diseases, viral pathogens looks very similar to what they have 2018. They added more on the bacteria stuff. Everybody knows, microbial resistance is a serious problem. MDR is a very serious problem. So also they put the dengue. Before they have mentioned dengue, but not so seriously. So this is, as you know, the NIH, they had their plan for all those protopathogens. Yesterday, when Dr. Tedros addressed this meeting, he also mentioned we need to do something for the prototype pathogens. Why is prototype pathogens? Because with this pandemic, everybody knows the virus worked very well. The virus worked together very well. We, the human beings, we don't work together. We are quarreling, we are fighting. The virus, they started with the prototype, and then they started with the alpha, beta, gamma, delta. Initially, the experts and WHO thought, oh, Greek letters, Greek letter, you have 24. At least 24 letters may be good enough. And when we got Omicron, and WHO realized, oh my God, maybe 24 letters is not enough. Like you said, the dengue serotype 1, 2, 3, 4. It could be, by definition, it could be 4 different viruses. Look at what we have for the SARS-CoV-2. Do you really think Omicron or XBB are they the same as the virus we discovered in Wuhan? That could be totally different viruses. So this is why, everybody is talking something about a prototype. And remind everybody, for the WHO, the fake public health emergency of international concern, we have been experiencing already 8 fakes for the 21st century. Of course, everybody remembered the H1N1, 2009 pandemic, and then twice Ebola, and polio once, and Zika once, and then we have twice COVID-19, of course, and then twice monkeypox. We are still in the stage of the fake. WHO claimed last year on August 14th, still not ended it. Still, we are still in the fake. And so think about it. Maybe while I'm talking here, we might have another corona or flu. Think about the outbreak at the moment in the US for the cattle infecting H5N1 virus. So what will we encounter the next disease X? It's arbovirus, could be dengue, chikungunya, everybody knows in China, Guangdong, Canton. This year, just declined a little bit. Chikungunya, dengue, this session we have been talking a lot about the dengue, or another corona, or it's flu. So before that, before we have the COVID-19, people talking about so many viruses. I was a member of GPMB, Global Preparedness Monitoring Board. It's under WHO. And in our 2019 annual report, 2019, before COVID, we claimed in the annual report, we might have a pandemic. What is the X pathogens? Which pathogens? Most likely, it could be either flu or corona, nothing else. So then, in 2020, we have corona. So after that, early 2020, I was attacked inside China, outside China. So you guys, you already know it's a coronavirus. You released the virus. Something like that. But even in that annual report, we claim human beings, we are not ready because we cannot work together. All this prediction confirms it's true. I can't predict now. I can't tell you now. If we have the next pandemic, the whole situation will be much worse than we have experienced because we couldn't learn any lessons from the history. This is why my friend said, okay, look at the English word. What is history? History could be dissected into high story. After this pandemic, we have written so many stories, high story, and then we forgot. So we just say high story, and then we are moving, and then we forgot everything. So this is remind you, I was invited on, remember the date, on October 18th, 2019, just before COVID. I was in New York called Event 201, organized by Gates Foundation and the World Economy Forum and Johns Hopkins University. We had this one, it's a table exercise. We have a suspected disease called CAPS, coronavirus-associated pulmonary syndrome. Read this, it's like COVID-19. That is named October 18th, 2019. And then I even didn't know all this picture. Look at this picture. And someone got this picture out from some web page. I don't know which web page, into Baidu and Google. Everywhere you see, even tour, you have this picture. George was sitting together with Abraham Haynes. Who is this lady? He's a deputy director of CIA for Obama administration. She is a chairperson for National Intelligence Council for Biden administration. Well, you know, and then conspiracy theory, everything comes out. Look, George is the China CDC Director General. And he went to the US working with this guy, CIA guys. They are planning something, you know. They are planning something. Look at all this as from, you know, why we have this event. And Tom and English Bay. And he thought we might have a pandemic. Why don't we set up a kind of a table exercise to see if we have a CAPS? You know, CAPS is the coronavirus. It's derived from Brazil, initially infecting pigs. It's a pig-derived coronavirus, and then spread as a pandemic. So this table exercise we plan for this videotaped, and this will be used for teaching, for Johns Hopkins public health students for teaching. So then it's not necessary to, you know, to have this video. We have a real pandemic in the real world. So this is, you know, CAPS. I give you, if you don't know this story, go on Google, Baidu, you will see all these stories. So now, and we had a COVID-19. So COVID-19 from a very beginning, you know, what we found the virus, and WHO claimed fake on October 30th, and then in March, they claimed a pandemic. So initially, it was in China, it's in Wuhan, and late December, we call it pneumonia of unknown etiology, PUE. And then, you know, we were attacked. Oh, this guy, they don't know this is the problem. So if you are working in the infectious disease field, if you know it's a flu, well, you know what to do. If you know corona, well, you know what to do. It's an RSV, whatsoever, you know. But if it's an unknown etiology, and also pneumonia, that means transmitted by, you know, respiratory system, it's air. So that could be a very, very serious problem for any professionals. So initially, and a lot of third-party companies, they caught these pieces of coronavirus genes. So then, you know, the internet, some news spread. Oh, SARS is back at that time, because it's SARS-like virus by pieces. You know, the third-party company, they are making their profit. They, you know, like ProImmune. I don't think you are doing basic research. Otherwise, how can you have so many, you know, staff working for you? You need to give them bonnet. You need to give them, you know, salaries. So they have pieces, not whole genome. Then the China CDC and so many teams, we got in, and early January, we got the virus. You know, it looks like corona. We released the data, and after release all this data, you know, in GISAT, no one knows. In WHO system, we don't have a place to release the sequencing genome. Go and find it. In the US PubMed or this system, it takes about a week to verify your sequence. So the quickest way, put it into GISAT. So we put it into GISAT. GISAT did it overnight. They are working day and night. Overnight, within 48 hours, they released everything on the 10th January. And then, you know, BioNTech and Pfizer, and also these people do the diagnostic case, well, everything done. And then my group also did the virus discovery. We did the we did the receptor discovery. We found SARS receptor ACE2 is also the receptor for SARS-CoV-2. We did all this, and it's published. Also, it's confirmed. Antigenically, it's different from SARS. If you have a SARS vaccine, it wouldn't work for the new novel coronavirus. Look at this. We got these monoclonal antibodies from KYUA, from Hong Kong. So from very beginning, we know antigenically, it's totally new virus. And then we did the crystal structure, all this, started to do the, all this vaccine development and drug discovery. So retrospectively, in 2016, I was asked by the journal Trends in Microbiology to write a review. The review title is Epidemiology, Genetic Recombination, and Pathogenesis of Coronaviruses with several of my colleagues. There we see it is likely not a matter of if, but when we might have a cold. The cold will emerge and cause another outbreak in the human population. So for any professionals who see this field, flu, corona field, we know we might have a coronavirus because we experienced SARS. And when you think hard, we have 7 human-infected coronaviruses. SARS, everybody remember, the first one, 1965, 229E, and 2 years later, OC43. Then 204, you have NL63, you have HK1. The scientists saying origin of the virus is a scientific question, but all the politicians, the public, they don't believe you. They think you know the virus and you release the virus. That's a conspiracy story. But I wrote something in 2021 in the Lancet to retrospectively to overview the origin of a lot of viruses, including SFTSV, including HIV, and also coronavirus HK1. It was discovered by KYUA in Hong Kong, but the patient is from Shenzhen, China. They published the paper of the HK1. And then scientists in Brazil, but really scientists, they have their biobank. They put up some material from their biobank. They found the materials for the PUE stored in their biobank, some materials from 1995. It was HK1. I think at the moment, no one wants to go back to say whether or not my lab, my biobank might have SARS-CoV-2 before 2020. So once it's politicized, I know no one wants to go back. But this one, because you are not in this field, I'm telling you, go back. KYU is HK1. And also name, by name, everybody knows why it's called HK1. Hong Kong University #1. You know what? OL63. OL63, the Netherlands 63. No one really read it. If you read it, Netherlands 63 and HK1. And then 2012, you have MERS. MERS initially was called HCoV EMC. EMC means Erasmus Medical College. And then the scientists, everybody in the Middle East, they are not happy. So hold on, guys. We never discovered the virus. Oh, found only one. So name back to the Middle East. At that time, everybody wants the name. No. It's not Lympha virus, not George virus. It's not Nick virus. What is the virus name? Now we name this alpha, beta, gamma, delta, and by then, no one can remember what is the virus. Ebola virus, you remember, Ebola river is in Africa. Oh, that's a virus from, first discovered in Africa. Now no one wants to have this name. Then you have COVID-19. During the pandemic, and the scientists working so hard, they found 3 sporadic animal origin coronaviruses infecting human beings. One from Haiti, one from Malaysia, one from South Korea. So in total, we have 10 known coronaviruses infecting human beings. Now, for disease X, think hard for the future, the strategy. What is the strategy we should think to control this disease X or X pathogens? Macro, I call the macro way. Use the preparedness for disease X, infodemics. I told you, the infodemics, also inflammatory virus, I named it. I give a name called infvirus. That is inflammatory virus. And government responses, policy formulation, impact of stigma, that it's, you have so many lists. And try to figure out what we can do in a broader strategic way, micro. Now, I think prediction is difficult to achieve, even we have the AI. Of course, we have to use the AI. And then we need to start the basic research and pathogen surveillance. Scientific about disease X, especially for the respiratory diseases. And what we needed to do, we need more experimental models. Though this is what I asked Jean yesterday, do you really think the animal model we can give up? I think we are not in that state. We still need to go back to test the animals, and the animal come back, like Linfa is doing for the bat, all this stuff. And for the respiratory system, how can we improve the protective efficacy of respiratory disease vaccines? So we think we always use injection, intramuscular, mainly. Maybe that's not the right way. We need to think something else. We also need to the antigen adjuvant. Can AI help us to design something new? So that's exactly something I'm doing. I was here 1 month ago. I'm talking something about vaccines. We are using AI to design nano-cages, not nanoparticle. It's a nano-cages because nano-cage provided you with a big hole. In that big hole, you can put a lot of immunogens. But nanoparticles, like any antivirus, any virus, is so intact, you cannot put any immunogen inside. So this is, I'm working in my lab. We have a lot of things cooking. Nano-cage. Nick, it's not nanoparticle. So this is something we are doing. And also, immunogen epitope search. So this is something we need to think about it. And then basic scientific question about mucosal immune response. We might need nasal spray, or also all this. We need to think about it. So this is a mucosal intervention and regulation strategy might be the future strategy. We think we know something, but for the mucosal system, to be honest, we don't know. And then clinical and immune characteristics, major clinical issues. Now the USA want to do everything in the non-animal model. So this is something we need to think about it. And also, the mucosal immune response, you need to think about the different kind of cells. And as for the influenza vaccines, I was asked from time to time, George, do you think every year you have the injection for the flu vaccine? Do you really think that's a virus? That's a drug. Every year, every half year. Maybe coronavirus, we need every 6 months have a jab. So this is something we really need to think about. We might change our idea about the definition of the vaccines. What vaccine mean? Maybe every month you inject something, or every morning when you wake up, spray in your nasal spray something. So this is really something we need to think about it. More importantly, come back to what I said about the WHO's definition about health, social, mental. So you have the vaccines for biological virus. Now we have social virus. This is infvirus. And you have the epidemic, biological epidemic. You have the inflammation epidemic. So this is infodemic, infvirus. Now you have a new category of science. It's called infodemiology. So this is why I'm writing a lot of book about public understanding of science. So this is, I'm doing the vaccination for the public. Tell the people what, this is then you will have 3 categories of health: social, mental, physical. So this is, I'm calling here. I wrote the journal I created, made it China CDC Weekly. It's an MMWR-like journal from China CDC. And So I say infodemiology, the science study infodemic and euphorus. So I named euphorus, euphemistic virus as euphorus. I hope this euphorus word will be the Oxford Encyclopedia. They would say, oh, this one named by George Gall one day. So yeah, this is the what I wrote you, the China CDC Weekly. So this is so many books. This time I took some books. For example, one of the books called Influenza virus, the inevitable enemy. Is published actually. It's called World Scientific in this country, in English, Chinese version, English version, French version, Russian version, and some minority versions, and also complicated Chinese, non-simplified Chinese version for Taiwan, Hong Kong, and Macau. And then you see so many books. So this is again, public health understanding of science is social vaccine. It's related to your work, remember. So challenges. We have One Health, and Elon Musk is going to take us to Mars. So One Health, global health, not good enough. No, planetary health. Our planetary health is not even universal health. We have so many names. What about the practical stuff? So anyway, I need just list of these. Think about our challenges. Lessons we learned. Science was attacked. The diplomacy, politics, public, so many things we need to think about it. We need to recover after the COVID pandemic. We need to recover the suppressed science. We need to recover the confidence of the public. The public was distorted. This is why I spent 1/3 of my time writing the popular science book instead of doing the science. I'm still doing science, but doing a lot of this work. So by the end, Louis Pasteur said, the microbes have the final say. Remember, I can't read this. I copied this from, you guys can maybe read the French. I couldn't, but it's in English. It means the microbe has the final say. So we should work together, really, my colleague, for the final strategy. What kind of strategy we should do? We must work together. So we must remember it's a globalization. We must remember interdependency. No one can survive in front of the COVID-19 virus like any kind of viruses. Or the euphorus. You might face so many euphorus. So this is why we should work together. So if we do not work together, the viruses will work together perfectly. COVID-19 virus, alpha, beta, gamma, delta, omicron, and then 24 letters are not good enough, and then they have, BA.1, and then they have BA.1, BA.2, XBB, now KP.3, KP.1. What the other name? I can't remember. Too many names. So the virus, they coordinated so well. Alpha doesn't work, okay, give your beta. Beta doesn't work, then omicron. After omicron, subvariants, tell me the name. So future strategies, what can we do? I was asked after Zika outbreak in 2018. So I'm still the advisory board member. What can we do for emerging, re-emerging pathogens? We can only do 3 things. So like when you buy a house, so always location, location, and location. For the emerging, re-emerging virus, always surveillance-basic research, nothing else you can do. You invest your money for basic research, build up the platform, like lympha, research these colonies, and understand bat immunity. We learn from the bat. So what I'm doing for the nano-cage, learning from the virus. I got some virus proteins, they fold, assembled into a very beautiful nano-cage. So our goals, remember those words, eradicate, eliminate, and control. Good example, eradicate smallpox, rinderpest, and eliminate polio, well-controlled hepatitis B in China. So by then, planetary health and One Health, we want human health, animal health, environmental health, we want Earth health, and we might go to Mars. So the vaccines, this time, for the COVID-19 vaccines, we have inactivated, live attenuated, protein subunit, viral vector, DNA, mRNA, virus-like particles. So far, knew all of this. My lab, we did the subunit vaccine. This subunit, the red one, And the purple with the cyan one is a dimeric receptor binding domain design. And we developed this as a vaccine, and we also put it into the trimer. This RBD could be trimer to broaden its spectrum of the neutralization. And we also developed therapeutic antibodies. You remember, Eli Lilly's has two combinations of the antibodies. One is anti-savimab from my lab. So that's a very good story from my lab. Basically, the research can lead to the products, can lead to the commodities, can save the life. So remember, if you are doing research, you should move on for this. So this Woogler wrote a book about the geological approach for to the vaccine development. It's unique. It's different from others. We use subunit vaccines, and this vaccine was used in Uzbekistan. It's the Minister of Innovation and Science and Technology. He said 66% of the vaccinated people used our vaccine. So we are in the AI era. Future strategy, think about AI. Detection, surveillance, vaccine development, drug discovery. You have to use the AI because we are like donkey. We cannot handle such a big data. We have to ask AI to help. And AI can help you to predict virus escape. AI can help you to design vaccines and antivirus. So finally, 4C principles for us to work together. That's very important. We should do cooperation, competition, communication, and coordination. I wrote this in the Lancet Public Health together with Nkangashaw. John Nkangashaw was the former Director General of African CDC. Let's work together. Do the popular science, public understanding of science. Whenever you come and visit China in Beijing, come to visit me to see this sculpture, influenza virus. It was erected in my campus to show HKOA influenza virus. Thank you very much. Some question? I think it's so clear, no question.